Yeah, my name is Chris Gratigny, and talking about my first LLM project. So about June of last year was when this started. And when I started, we started with just raw API calls. So yeah, we start with raw API calls. And what that meant is I was just trying to figure out, how do I actually talk with an LLM? What is the process? Because most of the time we just do it. We just ask a question and we get a response back. But how many of you have looked at what is the actual response that's sent to the LLM? What do you get back when you're having a conversation? Have many of you looked at that? Cool, so a few of you have. But so I started there with, I don't even really know what's going on. But I want to fast forward to this week a little bit, and then we'll go back to that journey. So recent journey this week is, so on Tuesday, that's March 24th, we shipped an AI analyst. So this is a project we've been working on for probably a little over a month since we got our first POC. Everything went way too fast because the leadership in our company is really, really excited about AI. And so we got done. So Wednesday, flew out here, and actually it's been going okay. Claude might have written many pull requests for me while I've been here, but we've been able to fix a lot of things, but it's going reasonably okay. So back in June was when I got invited to this meeting, which was, so I work for a security company, Huntress, and we were really AI skeptical. So that's when I got invited to this meeting, which is like, drop everything you have and come, we have a project for you. So went to that meeting, bunch of leadership. I was actually scared, like, what is going on? Also, one of the things that the CEO says is, hey, I need to guarantee that we get the same result from the LLM if we prompt it 100 times with the same question. I'm like, okay, this is gonna be an interesting journey. How are we gonna get there? So the journey went from, is working with the raw and Anthropic gem, which I wouldn't recommend anybody does unless you're gonna work with Anthropic for the rest of your life. So we started there because the CTO rolled a PR that he passed on to me and said, go this direction. So went that direction for a little bit, then got into August, and then, well, we probably should be able to switch to other models. So started working with RubyLLM. Have anybody worked with RubyLLM? So it's a fantastic gem. Carmine, I think is his name. He's Carmina, thank you. Yes, I know you know how you say his name well. He's been working on this gem, has had really great improvements. Really happy with what he's done. Thankfully, it's followed where we've gone. So went from one API call to now we have 17 agents, which are all making a decision for the investigation. So where we started was just the simple, we're doing an ask, but then I'm actually building the messages on the client, passing in the model, and this is something that's it's not maintainable, and it's actually really hard to find some of the initial code. But what I was doing with the Anthropic gem was sending out the requests. So we have the system message, then we have the user message. We send those out. We get back the assistant response. Sometimes the assistant response says, I want to call a tool. We then map it up to the tool. We send it back. Then we wait and we wait. So we started with that, and that was really challenging. We also started with, we have our prompt data. We send it to the agent, and we just get markdown. And then, of course, I had no idea what I was doing. So getting markdown displayed on the screen, I'm getting a lot of pressure of like, this needs to be in structured JSON. Like, okay, now how do I even do it and get it into structured JSON? So that was a challenge. And so what I learned by working with Anthropic gem, first of all, you get no model abstraction, no prompt versioning, which has been a huge challenge there. The API was actually really synchronous and fragile, and it was just you roll it and you say, oh, I got this error. Now let's catch this error and this error. Not something you want to do on your own. Of course, the Anthropic specific code, and we have token limits. We still run into the context window of 2000 200,000, we run into the 2 million, but now we're actually able to gracefully handle this. So the challenge that I had. So it was some of the feedback that I got. So when I switched to RubyLLM, it was actually as simple as we put in the configuration, we put in the default model, and we run with it, and we're able to do a simple ask with the configuration. Some things that we got for free is what RubyLLM has is you have your Access chat, Access message. So I had come up with all of my own stuff. So we have a conversation, and then we have these messages, and then I realized that conversation has like this groups of messages. So I created this message exchange model and was trying to roll all of that on my own. And got RubyLLM, realized, oh, we have this chat. And so whenever we ask a question, we have messages that belong to a chat. A much cleaner way of doing it. Also, of course, we have model agnostic. We can swap, Sonnet, Opus, or we can use any other providers. I actually haven't found any providers that have been better than Anthropic, though, for security. So we haven't switched, but we're ready to. Token tracking is built in. One of the things that's really great is there's actually a model. It's called model, which is really confusing. But your model has for each of the models how much input tokens cost, how much output tokens cost. So I'm able to say for each conversation, this conversation cost this many pennies or dollars. So we're able to say for an investigation, we'll be able to have the outcome saying each investigation, like I know right now it takes 2.5 minutes per investigation, but we'll be able to say it takes an average of this many tokens and an average of this cost just by the tooling that we have by using RubyLLM. Also, we have the tool definitions. When I started, I thought I was going to be working with an MCP server because that was all I knew. Well, I realized that you just work with internal tools. You don't have to roll an MCP server. It's just you have a class called execute, you send it stuff, and it returns back. So this is the RubyLLM architecture. We have basically you have the chat, you have the message, you have, of course, the LLM client, and then also creates a record whenever you do a tool call. So everything is stored. There's also some observability that you're able to get with Datadog as well. So what this allows us to do is anytime we ask a question and use the chat, it's all stored. So we can go back 2 months ago and then say what prompt did we have, because we might need to be able to explain ourselves. If we make a decision, we analyze something, there's a lawsuit, we're able to go back and actually say this is exactly what happened. Because a lot of times we just have a question and answer and we have no idea what's going on. And I'm also able to show, because of this is the prompt, this is exactly, so the prompt, the tool calls, everything, so the analysts can do a deep dive and they can say, oh, this is the information that we either sent or didn't send to see what we're actually doing. So yeah, our initial implementation is to go, I know I'm jumping back and forth in time a little bit. Our initial implementation is we thought AI can only do summarization. So we did only summarization. Our use case for a security company was we're going to look at all the Windows process events. We're going to have some determination on which process events are interesting, and we're going to show those events to the analyst. So that was our first thing that we rolled, because we're trying to not make decisions. One of the things that our CEO said is do not make any malice determinations. We do not want to do that. We'll never do that. That's not an LM job. And things change really, really quickly. Really, really quickly. What's been really fun is we have a Rails monolith. So being able to use Action Cable, Hotwire, all of the goodies is one of the favorite things that I get to do with this. So yeah, fast forward. Just talk about a little bit the investigation. The way that we structure the investigation is we have an orchestrator. So it's interesting. We chose not to use temporal. We might use it. Choose not to use temporal right now because we end up having an orchestrator that kicks off multiple parallel agents. Those agents come back and then we make decisions on what to do next. So we have up to 17 17 agents that are all doing their own analysis and coming back. So in the world, so I had no idea what protecting somebody's identity with Microsoft meant. So a little bit of what can happen is somebody can create a mail rule which forwards all of your mail, let's say that says password reset, to their email address. So they go to your banking, they do a password reset, goes through, goes to them, they now can drain your bank account. It's those type of things that we're protecting. So somebody creates a mail rule, it's going to trigger new mail rule created. Of course, we launched this, and there's an administrator who didn't want to see emails when her toner went low. Well, we definitely locked her account. We don't want her to be able to avoid those emails going to her inbox. So we've definitely made some mistakes. They did a group message because they were inviting everybody to this Disney hockey or Disney ice skating. Also shut down her account. So there's some things that humans would see that we're absolutely making mistakes. But in this we have all of these agents that are running. We have deterministic voting, and it says, has a low, higher, medium, and we have to get to a threshold for it to be malicious. What we've decided if we think it's malicious, we're just going to protect our customer, because we'd rather be cautious in the direction of we're protecting our customer than go the direction of not protecting them. So what we're doing there, it looks like, is everything that's not malicious that we don't auto-report, analysts look at. Everything that we report automatically. So we got here. It works. We had a small incident. Our VP of engineering is like, okay, well, how are we testing it? We got it. Now that we got it live, we actually lost our testers. So what that meant is we were running shadow investigations with analysts. That's great. Now we're running all on our own. We don't have any analysts. So I looked at the different testing approaches. And of course, do I want to use RSpec? Do I want to run it with a test suite? Not really, because how many times for us, our entire test suite runs on every single PR. We don't want to do that. I do not want to I just don't want to use Python. Maybe I'm lazy, but I'm just a purist. I just want to write Ruby. And so there's Gem, which they did a very, very minimal work on it, but it's been useful and building off of it. Called RubyLLM Tribunal. And so basically what you're doing is, and I have, basically what you're doing is you have a fixture similar to your tests. So you have a fixture, you run it through a real LLM call, and you get your result back. So when you get your result back, the fixture also has the results that you expect. So some are, we expect this JSON field to be malicious or benign. Some of it is we expect this or don't expect this. Something we found that LLMs love to talk about is impossible time travel, and they love to say, this person must have traveled from this place to this place at 2,028 miles per hour. And actually, that's not really helpful. It's like, who does that help? It's just showing off that you can do math, which actually LLMs do math very, very poorly. One of the things we learned in QC, because we're doing QC with our LLMs, is we did a QC evaluation, and all the numbers should add up. So I have one agent, and the agent gives scoring for 10 different items. It did not know how to calculate all the scores for those items to come up to a final score. It just couldn't. Over and over and over again, it did the scoring wrong. So I actually had to take the score for each item and then just do my own math. What's really interesting is if you have 10, you give 1 point to each one, and they get 100, it's going to say, oh, they got 12 points. You're like, I don't understand the math here. Or if you give 1 2 points and 1 4 points, it really, really falls apart. But that's when models come in, because when I used Haiku just makes assumptions. So give you a scenario. Let's say we have 10 criteria. The first one says 1 point. Haiku gives everything 1 point. Sonnet will actually read through and see, oh, this is 1 point, this is 2 points. But Haiku just basically makes an assumption that everything's the same, and it goes. So Haiku's faster, cheaper, and it actually is cheaper in the processing that it does. So went through all these, and basically we're doing, so we're running RVM Tribunal with our fixtures. So it's kind of custom, but I want to reuse a gem as much as possible. And one of the challenges really with Claude is it's really easy for it to just roll its own thing. And so we're trying to use frameworks as much as possible. So going back to this is what I was doing initially was we just get this markdown output. Well, now that we're actually trying to evaluate things, that would never work. So we're getting our structured results. Now that's been its own journey. I'm gonna remind myself we have next. That's been its own journey, because what we're doing is initially we take the markdown, we display it on the page. If I change the prompt and the information that's coming significantly changes, I'm just rendering markdown, it doesn't matter. But let's say I create a view and I'm getting JSON, and this JSON has a certain set of fields, the view is expecting those fields, and we remove a field or we add a field. Well, how many views are we gonna have to build in order to be able to deal with all of the versions of the prompt? So got into that, I was like, okay, this is just gonna be an absolute pain to deal with this. So we have, just give an idea of what our tools look like. First of all, trying to get so much out in this. Our structured results, I was trying to figure out how do we use structured results? It's like, oh, RubyLLM has this great thing where you just find the results that you want, try to use it, it didn't work. It just gave us, what they try to do is they try to take the response from Anthropic, try to parse it, and then get structured results. Absolute fail. So thought about it. Finally, I think it was something on YouTube, I realized that the most reliable way to get structured results is to use a tool call. So we end up having result tool calls that take whatever gets sent to the tool and do a halt. So you have your prompt, and then you say, now give us the responses in this tool call. In the tool call, you're able to require that you get an object, you get a string, you get an enum. Here's the options for the enum. So you're able to require the structured data in the way that you need it. So was a big discovery for me. Also, and see, so we'll look at the way that the tool calls are then structured. Is you have your inputs and their outputs. So I'm able to say, for this one, I have a param of content, it's a string, and a param of citations. So in this case, I'm only displaying the content to the user. But if we need citations for a background of, okay, why did we actually do this? We have our citations. So again, this is kind of the problem I was talking about, is what happens to the old views when we change the results, because I'm like, I want to get structured results, but I don't know how to do it. And so what we end up doing is we have this prompt table. So the way that we've stored them is I have using internationalization for all of the actual prompts. So we're testing our prompts, and we change our prompts in that file. But then in production, when it loads a prompt, basically takes the prompt from the international, from that from the EN, whatever I want to call it, from the YAML. It takes the prompt from the YAML, and then it looks in the prompt table for that exact prompt. If it finds that prompt, then it uses it and attaches a prompt ID to the chat. If it doesn't, then it creates it. So now every chat is tied to a prompt in the database. Does that make sense how I described it? So then if I go back and look at a chat a week ago, what we have is we have the system instructions, we have the prompt, but we also have the result template. So I'm able to look at whatever result template I had a week ago, and we're using Liquid for this. We're looking at the result template from a week ago. It's going to have, let's say, less information than the one today, but whatever template we had at the time the conversation happened, we're able to preserve that. So that's something that as we're building this, I'm finding that we're doing a lot of work with the prompt, but there's a lot of just framework around this. And maybe there's things that I'm doing wrong. Actually, I know there are, and we'll figure those out as we go. But there's more around it. So yeah, this is the prompt model where we have archived at, so it automatically archives it, system instructions, prompt, result template engine, because of course I start off with interpolation, our requirements grew. We need to actually have an array of objects. So we started using Liquid, which has been a lot easier to use. So this is just I showed this before, didn't I? Yeah. So this is just our agent-based process flow, just as a reminder. So we have our, this is different, sorry. I tuned my slides this morning, and so some of them are a little bit different. So this is when we get into the agent eval. So we get into the agent eval. So previously on the right, we have our prompt, which does a tool call. Now what we have instead of that is we have our fixtures. So we have fixtures. Each prompt right now, or each agent has at least 5 fixtures, and then we just add to them just like we would in normal spec as we have edge cases that come up. Like we had a really interesting one this week where we do event summaries with our incidents that we send out, and the LLM just argued with itself. And it said, I actually can't do what you're asking me to do because I don't think this should be a report. And we send that to a customer. So we then take that and actually, I don't think the customer actually, the customer didn't even look at it, unfortunately. But then now what do we do? Well, we get a test in place. So we have a fixture with that data. And we couldn't have done this without the structured results. The agent eval, so basically what it does is we load the prompt. Then because it renders it with Liquid templates, we're able to stub all of those. So it stubs the tool calls, all of that. And then we actually do a real LM call because we don't know what's going to happen between 4.5 to 4.6 to 4.7 to 5.0. We don't know. I know I have a Slack channel which has all of the messages saying that Sonnet, Opus is degraded. We're seeing errors, but it just keeps on working for me. So I don't really. It's really hard to tell. Is it working? Is it not working? Sometimes it does go hard down every once in a while, but it's so difficult to tell. Is the model actually behaving as it should? That's why I'm not gonna trust it, but I'm gonna do it myself. So not only are we running this in development, but we're also running this in production. So about every 2 hours, it'll roll through all the agents. We only have 40 right now, so this will become unmaintainable in the future. But we have 40, and so I can see how many agents are green, and we can get a baseline of, okay, maybe this agent is going to be less reliable. Let's look at that. Let's get it. How can we tighten this up? I've definitely found also that using Claude to work with this is incredible because you're basically able to say, how do I talk to one of you? I had this input, I had this result. I don't like the result. How can I better prompt to get this? Claude has been fantastic there. So with this, we have the tribunal investigate evaluation. When our fixtures, pretty simple. So we have agent name, and then it has expected. So in this one, it must not include this. It must include, we're able to actually do tests on evaluations on some of the specific fields in the JSON as well. Then this is just another example fixture where we have expected, must not include, must include. So I wanted to show a little bit of what the code looks like so it's not all abstract, because most things with AI feel like they're just very abstract. So now we have the scheduled jobs. We've gone back and forth between having every job run every minute, all the jobs run one at a time. Thankfully, it's really easy to do that, to switch back and forth. Or sending all the metrics, of course, to Datadog so that we have a dashboard in Datadog showing us how long how long it's running, the success failure of the jobs. Of course, we get failures and notifies us in Slack, so we're able to know we should check this out. And yep. So how are we doing on time? As Nathan starts to move, I know I'm pretty close. Cool, I'm almost at the end. So what I found is I would say that Ruby can be a first-class LLM citizen. RubyLLM happens to be the tool that I am using. It's being updated very frequently. It makes it incredibly easy to work with. You can call it without creating all the models and just do a really simple prompt and get an answer. You can have the model chat and messages. You can have all those that has options. So that for me, starting with the raw API, that was actually really good, a really good thing for me to start with. And now as engineers start the project, I actually referenced, okay, let's go back, way back when I started this in June. Let's look at the initial call so that you can understand what's going on behind the scenes. Because so much of it is magic, it's actually it's another API. The LLM's just an API that we're sending a request, we're getting a response back. There's a lot of magic, of course, in the model, but the API in itself is really nothing novel. And so being able to understand that, I think, is really valuable. What I've learned is also I should have built the eval system before we launched to production, because we're catching up. Because we end up having something out there that's like, well, what does happen when we change it? Part of that's just how do you say no to leadership, and that's kind of hard because they pay my check. Also, there is such a challenge of testing the LLM, but there's so much that we can deterministically check. So it's easy to kind of say, oh, this is LLM, I can't test it, but you can test so much more. And I realized along the road of doing this that not that I got lazy in testing, but you can get a little bit lazy because you assume that, oh, the LLM is just non-deterministic, but you actually can test more than you think. Also, the feature flags, kill switches are so important in this because we have to, basically, we're creating an autonomous assembly line. So this agent is going to make a decision. It's going to go all the way through. I don't know if any of you have watched like the movie Megan, and that's what keeps me up at night is what happens if the agent thinks everything's malicious, everything's benign, and people could lose thousands of dollars. They could lose their business if we're not protecting them as a security company. So like, what if somebody gets ransomed because our model just didn't break? That's what we're looking at as far as risks. And so we need to be able to, for operations at any point when we launch this, they turn it on. I wasn't the one turning it on because we go around the clock. I don't want to have to be getting up at midnight if we need to turn this off. So kind of the summary of my story, and I asked, we use Glean for this. It's like where I started. I was like, can I have an API key? And what are we doing? To now we have a system that's autonomously protecting customers. This week, I think already it's sent almost 1,000 reports out. And what's really important to me, every line of it is Ruby. So, that is it. And cool. Yep. And I think I ran into time, so we're not doing questions, right? Is that? If you would like to take a question, you got time? Yeah. Yes, you mentioned that Anthropic Yeah, so we're using Sonnet. We're gonna use probably Opus a little bit more. So how do we come to that conclusion? Was by first of all testing other models, but also in the research that I've done, is security companies are using Anthropic more than any other models. It's like the OpenAI just isn't trained for security as much. So it's just looking at all of the looking at the models and saying what data are they trained on, and then Anthropic is actually rolling their own security tool, and so when they rolled that, I'm like, well, this seems like a good direction to keep on going. So yeah, just look at what are they actually trained on, because all the models you can find if you go deep what is the data set that they're actually trained on.
You asked yourself the question, how am I going to tell them who's online to have it that's just blessing everything?
Mm-hmm.
Do you have anything where you check your AI's responses against another model? Like
Mm-hmm.
like say okay, like 1 out of 10 times give that same query to OpenAI and see if it gets the same answer, and at least get some flexibility in auditing. I know a lot of coaches do that.
Yeah, we're about to do that. So we're not doing that right now, but we're actually looking at running parallel investigations and then running the QC against devil's advocate against both and QC against both. So right now, I mean, when we actually launched, so the last Friday I was in a meeting and I said, we don't have guardrails. Do you want to launch? And people were really excited about launching. So like, okay, we're doing it. So, yeah.
You mentioned the security parts of training the model, so about it.
Mm-hmm.
Did you consider any other measurements, either the performance, the quality of results? So the models are really different.
Right. So I actually considered different vendors than Anthropic for Anthropic's models, like Open Model, because Anthropic's downtime isn't great. But we were primarily looking at security. We weren't looking at speed. We were looking at accuracy. Cost wasn't a factor either. But yeah, I did look at some purpose-built security models, but then you get into actually training the models, and that's something at least I'm trying to avoid. Is that I don't know if anybody here has tried to train a model, but we haven't got to the problem where we need to get there. Well, I think it looks like
awesome.
lunchtime.
Yeah. Thank you, Chris.
Yep.